And we are live. Hello, everybody. Thank you for joining us today. This is the very first episode of the video podcast or show, or whichever one you want to call it, called Weekly Supervised. Today, we were planning on having 4 panelists. Unfortunately, one of them is having some technical difficulties, so we are starting right on time with the other 3 panelists. So before we start the conversation, I just wanted to give you a few kind of logistics, or housekeeping items. So there are going to be more of these shows. It's going to be a weekly thing, same time every Friday, 2:30 Eastern time. We'd love to have you, come back and watch and interact with the rest of the episodes. We have a lot of very nice topics coming on, a lot of different guests. This is the only panel in our season 1, which is going to be starting today all the way to the long weekend of Canada Day, which is the first week of July. If you want to know about those topics, when those events are, please follow us on our LinkedIn, subscribe to the same YouTube channel, and also underneath the same YouTube link, you can find the links to our LinkedIn as well as a Slack workspace where you can also join and submit your questions over there. There's a channel called Events Question Board. I will try and monitor that as much as possible, and if time allows us, we're going to try and ask some of your cool questions from our panelists today. Those being said, without further ado, I would like to start the real conversation, the panel itself. We have 3 very prominent panelists today, and instead of going with a dry, very formal, official introduction, I asked everybody to give us a quick intro about themselves, about what they're doing for a living, about their experience and expertise, specifically in the realm of natural language processing. So I would like to start very randomly asking, the first person who joined the meeting today. So I'll go with Suhas first, and then you can nominate the next person if you'd like to.
Okay, thanks, Arman. So thanks for inviting me, and sorry for the absence of my webcam. That's Zoom Live. Anyway, I'm really excited for this discussion. So as Arman said, I'm Suhas Pai. I'm currently the CTO and machine learning research and developer at Bedrock AI. We are a startup based in Toronto, and we launched recently, so that's really exciting. So we apply NLP to the world of corporate disclosure, and our mission is to make this legalese and financial jargon and buzzword-laden text understandable to all, as well as be able to retrieve and extract all kinds of insights and relate it to specific outcomes, be it fraud, bankruptcy, etc. And we actually have heavily leaned on modern NLP to build our products, but we did give so-called classical NLP a shot at the beginning. More on that later. At Bedrock AI, my focus areas include researching ways for language models to efficiently and effectively handle longer contexts, pairwise ranking strategies, and lately I've been focusing on hallucination-free abstractive summarization. I conduct independent research in my free time, where my passions lie in the area of controlled text generation, neural style transfer for text, and privacy-preserving natural language processing. And I also host a NLP paper reading club every week, where we do a deep dive into the most recent papers in NLP and debate its merits and demerits. So that's it for me. I nominate Soumya to introduce herself next.
Okay, thanks Suhas, and thank you Arman for organizing this event and inviting me to be on this panel. My name is Soumya. I work as a researcher at National Research Council in Canada. NRC is Canadian federal government's largest R&D organization, and I work in the multilingual text processing group here. And so my background actually is in NLP. Like I've been working in NLP first as a software developer, and then I moved to do my PhD in Germany. And then I taught NLP for some time, and I was a data scientist for some time in the industry, and now I'm a full-time researcher again. So I think I explored all sorts of career paths in NLP over the past decade. And I primarily work on the application of NLP to educational applications like essay scoring, analyzing text complexity, doing text simplification, these kind of things. But I also worked on a range of languages, I mean, human languages, not machine languages, and also on developing tree banks and those kind of like basic resources for new languages. While in industry, I worked on problems like deploying a comment moderator on the Globe and Mail, and various kinds of text summarization, key phrase extraction, things like that. I also wrote a book recently. It's called Practical Natural Language Processing. It was published by O'Reilly Media last year. And yeah, other than that, I also teach NLP at various locations sometimes, and I really like teaching. I don't have to nominate anybody. There's only one person left.
Hello, I'm Charlene Chambliss. I'm a machine learning engineer at Primer AI. I have a little bit of an unusual background, I guess, for the field of data science. I originally studied psychology in my undergrad, and so I learned all about the mind and why people make decisions, and I specialized in health in particular. So I've always been interested in the ways that like our physical health and our beliefs tend to be related. And so I got to do a bunch of cool lab experiments in school about that. Then I spent around a year doing social media marketing. Didn't super connect with that particular career. And then that was the point where I kind of decided to get into data science. And so if you fast forward around 2 years through 3/4 of a master's degree and a bunch of self-learning and my Sharpest Minds mentorship, here I am now. I've also worked in data science at Curology, which is a D2C skincare company. Let's see, the types of problems that I've worked on at Primer have primarily been classification, NER, relation extraction, so kind of your bread and butter like NLP tasks, as well as some various like data science experimentation as needed to solve particular problems. And right now I'm on the Automate team within Primer, making AutoML with cutting edge NLP as super easy and drop dead simple as possible. So I've been doing a lot of like research and experimentation to power like some upcoming like ML features within the tool.
Amazing, thank you, all the three of you. I think the type of work that you guys are doing is super exciting, specifically to myself. I'll also do a little bit of an intro, and thank you, Charlene, for reminding me that I also wanted to talk about Sharpest Minds. So coincidentally, or maybe intentionally, all initially 5, but now 4 people who are on this call are members of the Sharpest Minds community, mentors, ex-mentees, people who are super active in that community. So for those of you who want to break into the market of analytics and data and AI, and specifically natural language processing, if you are in North America, I really encourage you to take a look at Sharpest Minds. It's an amazing platform that helps folks, gain a better understanding, get hands-on experience, and also there's a very nice support mechanism to help you, get your first job or get a better job if you have been, in other areas of technology. So on my end, similar to everybody else, I'm also, a mentor on Sharpest Minds, but for my full-time job, currently I am working with a company called Mighty Hive, so I'm the Director of Data Solutions in Canada. Prior to this, I was with Deloitte Canada for a couple of years, where I was also mainly building NLP products for both internal and external clients. I cannot claim that I am as expert in natural language processing as the rest of the folks here. I'm more or less amazed by the type of work that these folks are doing. So that was the main reason behind me trying to use this use this event or this rouge to get everybody on a call to try and get some of your experiences and kind of broadcast it to the outside world. So with that being said, I would like to officially start the tough questions. Now, in order for us to have a kind of common language, and please, anybody feel free to, take the question or challenge the other person if you'd like to. There's no real structure here. But I'd like for us to kind of first start by creating some sort of an agreed upon infrastructure. And I think the first question in order to build that would be, how do you define NLP? You mentioned a few tasks that, that NLP entails, but if we wanted to go a little bit deeper into that, how you define it, how you put it within the world of AI or even machine learning, and if you could also kind of elaborate a little bit more about kind of similar or sub worlds related to NLP, specifically speaking natural language understanding and generation, which I heard a couple of times in the intros. That would, I think, give everybody a good starting point, and then on top of that we could go into the landscape of classical versus modern natural language processing. So I don't want to nominate anybody, so whoever wants to go first, please go ahead.
Okay, I can go ahead first. So I mean, I don't want to give a definition kind of thing, but I would see everything as like both natural language processing and machine learning as subfields of artificial intelligence. So NLP overlaps with many other fields, like say there's an overlap with linguistics, human interaction, even psychology and cognitive science. I would prefer to see it like from an engineering perspective. I would prefer to see it as a subfield of AI as well as ML. So ML is also a subfield of AI, and I see NLU and NLG as subfields within NLP. Although like there are people who exclusively work on NLU or on NLG, and I mean it can be like it's a name on its own, but I would see it as a subfield of natural language processing.
Awesome. Anybody here who would oppose that definition?
I definitely wouldn't oppose that definition. I would pretty much agree. NLP is definitely like a subfield of ML and AI. And in fact, there can actually be a lot of traditional ML and NLP, like kind of problems of figuring out like similarity between two documents, which will use a lot of traditional ML sort of stuff like distance measurements and things like that. Clustering, sort of your standard ML stuff. And in particular for NLU and NLG, I don't know, I've never really liked like distinguishing all these various areas of NLP, because like you need all of them in order to like make a model that actually functions well for a task, especially if it's a difficult task. So like even if your question answering task is not actually like the model actually understanding or something like that, it needs to be able to do like some sort of reading comprehension in order to actually get the answer. And so, yeah, I think in that sense, I think the distinctions aren't as strong as we sometimes like to think.
Beautiful. I think I agree with you. Anything to add from you, Suhas?
Yes, I agree with everything Soumya and Charlene mentioned. With regards to NLU and energy, I think there are like several tasks where you need both of them. For example, if you have, I don't know, like take for example the task that I've been working on recently, style transfer for text. You need a solid understanding of the text to separate the stylistic component from the content of the text. And then if you want to change the style, that's a generation task.
Amazing. So I think that is actually a very nice segue into the next question. So we know a little bit about the things that you guys are working on right now. If you were to look back maybe 10, maybe more than 10 years ago, and use the tools that we had in our toolbox of classical NLP, before the revolution of deep learning, do you think that, first of all, how would you describe that landscape in terms of research and applications, in terms of maturity of them, obviously, and what would you think that we could have built in that classical NLP era? And do you think that the things that we are building in terms of software products these days, specifically in the past couple of years, they have a chance of being a software product, let's say 10 to 15 years ago? So maybe you could use the reverse order, and then for every other question we could just change that order. So in this time, maybe Soumya, you want to start first because you used to be in that world a lot and teach that actually. So maybe you could start that conversation for us in terms of the landscape of classic NLP.
Sure. Actually, I mean, if I have to answer this question in one sentence, I don't think there is a dramatic difference in terms of the applications we are doing with NLP even now compared to 15 years back. I think some of them just got better because of recent advancements. Like say, I mean, if you look at machine translation, Google Translate existed 15 years ago. I mean, not maybe 15 years, but around that time. There was search engines were there. People were working on summarization. People were doing a lot of classification stuff. There was NLG even then, like weather reports and these kind of there are companies that do this kind of domain-specific natural language generation kind of stuff. There are some kind of chatbots, although not as widespread as now. There were some kind of conversational agents even 10 years ago. So I don't actually think we have. I think the landscape of applications just remained the same, but how are we developing these applications and how good are these applications? I think that changed a lot over a period of time. If you used Google Translate, say in 2007 or 2008, and if you're using it now for a not so commonly known language, you can see the difference. Maybe some combinations like English to German or something like that, maybe you don't see dramatic differences, but say I speak a language called Telugu, spoken in southern India. It's not as good even now, you still see bad translations, but it's much, much worse 10 years back. So that's the distinction I would make between classic and modern NLP, not in terms of applications, but more in terms of methods.
Yes, I agree. So I was first introduced to NLP in 2009, and that was before the deep learning era. So during that time, I guess the applications that I was working on are more or less very similar to the applications that people are working on today, but the techniques used were different. So I remember after working in NLP for a few years, around 2012, I left that field and went to the field of information security. I worked there for 4 years, and when I came back, deep learning had taken over. The field was almost unrecognizable. Every new paper was talking about deep learning, neural networks, and they were all, just making one architectural modification after another to recursive neural networks, and the subsequent architectures that came after that, like transformers, etc. So while the techniques have changed, definitely, I don't think that the applications themselves are, there has been a significant change in the type of applications that have been worked on. And also, I think there is definitely as Soumya mentioned, there is definitely a dramatic improvement in a few instances, not so much in several others. So I remember I used to live in the Netherlands back in the day, and at that time when I first moved there, I didn't know Dutch. So my landlord, he gave me a copy of the rental contract what he did was he just pasted the Dutch contract in Google Translate and gave it to me in English. And at that time when I read it, I couldn't understand a word of it. I thought it was like some fan fiction because it had totally, I don't know, recognizable words that didn't have anything to do with housing or utilities. So anyway, and today we know that landlords can definitely use Google Translate for translating their rental documents without any liabilities. But this was an interesting thing that I was recently looking at the classical textbook of NLP by Dan Jurafsky, the first edition written in 1999. And in that, there's a passage that stood out. He was saying that these are the new, I think, applications that people are working on. And one of them was a computer equipped with a vision system watches a professional soccer game and provides an automated natural language account of the game. And it's 2021, 22 years later. Have you managed to do that? Not yet. So a lot of things haven't changed, even though people were pretty confident even back in the day. So yeah.
Yeah, totally. I agree with the sentiment that applications haven't changed a whole lot. I would say that the methods that we're using have created some big breakthroughs, specifically in terms of access and in terms of performance. So previously, looks like Sonia is having a little bit of an internet issue. Hopefully she'll come back. But previously, like, expert systems were kind of the name of the game if you wanted to use NLP. So basically what you would do is you would hire a bunch of really expensive domain experts, or like people who were translators or like actual linguists with PhDs, and you would have them like write you down a bunch of handwritten rules, and then you would program that as like one big if-else statement to make your program work in order to like process your big document pipeline and get what you wanted, like a translation between English and German, for example. But now we have models that kind of abstract a lot of that away. So they actually just like learn the different patterns of language, and we don't need to like write down and specify those rules for them. And so that's made it a lot easier for like companies who don't have the budget to hire 1 million experts to actually apply these systems towards the particular problems they want to use. And in addition to that, we also have like much more widely available compute access. So it's, even with some of the classical algorithms, it can get kind of tricky trying to run these on like a CPU if you have like anything more than like 1,000 documents. And so having GPU access actually makes it so that like we can compute these results in the cloud and then actually bring them back to where we want to use them. And it's just a lot more feasible in terms of like time to results. And so that's kind of the two areas where these methods have really like changed things in terms of the applications of NLP.
Amazing. I'm really glad that you brought this, the 2 points up. So one is in terms of training models on cloud and having access to better compute power. And then the second one is the subject matter expertise that we used to heavily rely on, I don't know, maybe until a few years ago. So in order to ask a follow-up question, maybe I'd start from there. Do you think that the role of those subject matter experts are kind of vanishing these days, and are we only kind of relying on them maybe for labeling, or maybe coming up with some sort of heuristics that would help us in terms of defining the tasks or things like that? Or do you think that there is still a huge dependency to those linguists who used to be on the team building those softwares even today? So that is probably the first question, the first follow-up question. I also have another follow-up for pretty much all of you when it comes to the biggest agent of change, which is having access to public cloud. So I'll pause there and let you elaborate on your thoughts on that, and then we'll get back to cloud and compute power.
Yeah, I can quickly answer the subject matter expert question. I would say, unfortunately for linguists, they might not be quite as needed anymore. in terms of other types of domain experts, like we definitely need subject matter experts. Just think about like a biomedical entity extraction task, for example. Like maybe you're trying to identify like chemical compounds in a document or like medical symptoms in a document. You need someone who's like trained in identifying those things in order to actually label that data so that you can train a model to do that. Because if you just try to outsource that to like people who don't have any sort of special training in that area, like the data quality you get back is going to be pretty bad and your model is going to suck. So we at Primer still believe pretty strongly in like human in the loop in terms of like building our own AI models. And that's definitely something we're also seeing like reflected in the industry at large still.
Okay, I would like to add to what Charlene said. I mean, I think there's subject matter experts have a role to play, and also linguists have a role to play, because even now, like if you look at large companies, Google, Amazon, and even smaller companies like Duolingo and Grammarly, they keep continuously advertising for different kinds of linguist positions. Some people advertise for like, so I mean, when I used to teach, my students used to attend these interviews, and even last week, a linguistics student messaged me saying she attended some Google interview for an applied linguist position. These things range a lot. Like, I mean, sometimes like a student who attended this Grammarly interview said she had to actually draw syntactic parse trees and explain grammar rules and things like that. But then it's that's not like always the kind of role that linguist plays. Like, say, for example, I heard about some interview with Google's chatbot team where this was more like writing some rules and understanding where the prediction errors are coming from and these kind of things. And I think there is a lot of annotation work involved also, especially with these companies that are building exclusively NLP products. Like, I mean, not something like where NLP is a feature in a larger software product, but the product itself is an NLP product, like say Google Translate or something, or even Google Cloud Services like Google Cloud NLP or Azure Text Analytics or these kind of things. So I think there is like, I mean, I don't know, I can't predict how long is this going to be, but I think for some time to come, there are going to be some jobs for linguists in these areas, both creation of data as well as doing some kind of quality analysis, quality assurance of machine learning systems. And a lot of these systems are some form of hybrid. Like, even if you look at these tools like Spacey, source code of Spacey and tools like that, you see a lot of heuristics based on linguistics underneath them. Not always just regular expressions. There are a lot of other things which require you to have some kind of linguistics knowledge. So it's not always engineers writing this code. It's also a lot of times linguists who learn to program. So I think linguists and subject matter experts are not going to go away anywhere. We may not see them, we may not work with them because we work at a abstracted level, and we also work with sometimes pre-trained models and things like that. But if we go if a new application comes up, we need subject matter experts, potentially also linguists sometimes, to create the data sets, and there are like tons of languages for which we still don't have any support. So I don't think linguists and subject matter experts are going to go away anywhere, and we may even end up learning some of those skills, and they may even end up learning some of engineering skills as time passes.
I think I agree with you, and so as just before I let you dive into this, I also wanted to read a comment that one of our audience members has written onto our Slack channel. They're saying that, and I'm just reading off of their text. So they're saying that as a newcomer to NLP, I would say my main concern about the modern versus traditional is usually interpretability. I find it difficult to understand some modern concepts if I don't go back to study the statistical traditional models. Also, modern NLP is a bit expensive in computing. So again, good segue into a computing conversation. I can't always find the hardware to run my code. Good points. I've heard the exact same comments from a lot of different people. I just wanted to add one more quick thing before we go into the realm of cloud computing and compute power, and that is regarding or related to subject matter experts and specifically linguists. I think I also agree with you, Soumya. I have seen a lot of hybrid teams where, I mean, if I wanted to talk specifically about feature engineering, the team that were working on the NLP product, they heavily relied on, let's call it traditional feature engineering as well. And in their specific domains, similar to the domain that you were talking about, Charlene, in medical, for instance, they still needed to find, so to speak, rules that would define those features. So again, classical plus maybe modern NLP. You know, I only hope that we could always use that hybrid model, despite the fact that I see a lot of new companies, maybe startups, that heavily rely on just adding more data and just dumping it into some sort of a deep learning scheme. So as you were going to add something to it, apologies if I cut you. Please, by all means, dive into and elaborate.
Actually, I was going to say that I completely agree with what Soumya and Charlene said, but just to play devil's advocate and just to stir the pot a bit. So I think even back in the early 90s, there was this famous quote about, you know, every time I fire a linguist, the accuracy of my speech recognizer goes up. So I know that that there is a lot of discussion about the role that linguistics has to play, and it's quite evident that it still has a very large role to play, but just some personal experience. And I'm not saying that this one anecdote is indicative of anything, but just from at my company, we paid a lot of respect to computational linguistics and cognitive science, etc. We at the beginning of our research, we were heavily focused on that. But so, and this is coming from someone who was actually a little late to the neural networks party, because I was skeptical of neural networks when it first arrived, or when I first started learning about them. But anyway, what happened here was that the moment we went all in on, you know, big data, big networks, we had our first major breakthrough when we so when we, you know, said goodbye to all, you know, accepted practices of computational linguistics, you know, all the linguistic features, etc., and just went all in on getting as much data as possible. And but again, it's not just making it simpler by throwing in data. There is a lot of engineering involved in getting the right amount of data and the right amount of model, the right architecture for the model, etc. But yeah, we did see a dramatic improvement just by using modern NLP. Again, it's just specific to my circumstance and not really indicative of the field at large.
I cannot agree more with you. Yes, so I have, you know, because of my previous job and maybe my current job as well, I have had the opportunity to talk to a lot of early stage startups all the way to scale ups. And if I wanted to sample, I would say from the number, and I can't really know for the life of me what that number would look like, I'd say maybe only a small percentage of them were following the right way that you were just talking about, Suhas. So I think that could potentially, I mean, being data scientists and machine learning engineers, we're always looking for, you know, indicative features, right? So that potentially could be a feature that could tell us whether or not the startup is going to become successful in their journey, because they know, you know, they have plans and they know how exactly they want to go and operationalize it. So thank you, all three of you, for you know, answering to that question. I think that kind of opened a few you know, a few doors for me to maybe some questions that I have not had written here for you folks. Maybe, you never know, maybe in the future event I could have maybe one or two or all three of you join again and we can talk about those questions. But going back to cloud, and again, this is something that I think we have all dealt with, and it's a problem, it's a challenge for specifically people who have recently started working in the realm of natural language processing. What are your thoughts if I'm a newcomer and I want to start, not only playing, but I have a cool idea and I want to actually start building a prototype, and I want to, use some sort of a public cloud instead of, a server that I would go and invest in it. What are your tips? What are your tricks? What have you learned over the past couple of years that you think are, requirements for somebody who wants to start right away? And they shouldn't really make those mistakes when they are trying to build a prototype.
I'm sure others will have more comments on this because I don't have a lot of experience with this particular aspect, but I still want to add one comment here. My single advice would be start simple. Start with a minimum viable product. Don't start with the most complex solution out there just because it is state of the art, because it may also not work out for a small company in terms of its finances. So that's the only thing I would say. Start simple and build incrementally.
Yeah, I would agree with that. If you're new to the space and you're like, how do I use my compute time wisely since this costs money and I don't have a job yet or something like that, you want to start with things that, maybe have tutorials that you can follow. Start with maybe a simpler task like classification as opposed to a little bit of a more involved task like token level classification, so NER, for example. Do something where you can kind of start learning quickly and getting feedback quickly on how you're doing, as opposed to inventing a new architecture from scratch or something like that, which may take a much longer time to pay off. Just kind of use your time wisely until you do have kind of the financial backing to explore more complex areas.
With regards to infrastructure, I would say Google Colab is really a boon. I think Google Colab Pro comes with, I think better time limits, etc., and it's just $13 a month. I promise I'm not an employee of Google or from their marketing team, but if you are starting new and again, after echoing Soumya and Charlene's point, and if you want to say train neural network models, etc., I think one of the best ways to get started is go to the Hugging Face platform where they have a bunch of notebooks listed. Go and try to run these notebooks, and then you can change one aspect here or there and experiment how things run and so on. So that would be a good place to start with the more advanced techniques. But I think you can always, start from the basics. If you are already comfortable with more simpler models, then that's pretty good. You can get around to working with these neural models and on Colab as a start. You don't need to buy a GPU right away.
Yeah, just to add on to that real quick, there are also some cloud services that'll literally just give you some free credits if you're a student or a researcher or something. So make sure to kind of do your research and look into those kinds of opportunities in addition to the free platforms like Google Colab and stuff.
Brilliant. Yes, so definitely agree with all the points here. So related to that, I would like to maybe ask you a question that a few others have asked me in the past couple of months. It relates to Soumya's point that you should always start with, with something small. Versus also it relates to what Suhas was talking about in terms of, Hugging Face and similar products, obviously. So the question was, and I'm just paraphrasing, it looked like something like this, that, hey, if I have access to Google Colab and I can go ahead and fine tune, BERT or maybe a new version of BERT that like they pop up here and there every other week. Why do I need to go back and learn the basics? Why do I need to go and try and implement something that vectorizes a document using TF-IDF? We know that BERT is going to be much better, and it's not going to be as expensive because I can run it on a free cloud such as Colab, or with only a few tens of bucks of dollars a month, I could probably build something that is going to definitely be better in terms of whatever metric that we're interested in. So what are your thoughts on that? Should people kind of put aside everything that stands for and holds the flag for old NLP? I don't want to call it classic NLP, but not necessarily something that we were using before the emergence of BERTs and GPT-3s? Or do you think that it's something that everybody needs to know in terms of the basics of how those models work, because it is going to help them understand the new ones, and specifically when it comes to vectorization of text?
Yeah, I can start, I guess. So it's not just only about understanding how things work. Like my comment was more also in terms of putting something in production. So we see a lot of improvements with BERT and with many other deep learning models, but on specific tasks. Like say, take machine translation or speech recognition or something like that. But those are not the most common use cases in many software companies which have, like, say, NLP or some kind of AI as a feature in a bigger product. So it may turn out that sometimes, I built some system, I don't know. I mean, I can take the example of this comment moderator we built for Globe and Mail. The one that was deployed first, for the first version, was actually a logistic regression model with simple TF-IDF kind of features. And there was a reason for that. The reason was the deep learning model, the improvement with the deep learning model was not like, it didn't warrant changing from this logistic regression on production system. It was like 2% or something like that. I don't remember that much now. And the fact that we have to constantly keep changing this model, like every 2 months or something, the model has to be updated, new data has to be created. Sometimes, like, I mean, it may not make any sense in those contexts to use, say, BERT or even more advanced model like a recent model. For this reason, I think sometimes there are also cases where it just works, but how will we know that unless we try a simple approach and like that? That's why I say start simple and build incrementally, because that will give us the best solution, in my opinion. Okay, you may start with BERT, it may give you the best solution, but who knows? Like even a simpler model may give you equivalent performance. How will we know unless we try it? So that's my take on that.
Exactly. I think it
for research it's not necessary. Sorry. If you want to publish a paper, it's not necessary. I mean, I'm a researcher. I don't do this. Like, I do this only when I'm building something.
Yeah, exactly. So one thing that I think needs to be noted is that BERT is not like a strict improvement over traditional NLP models. So you always lose something in order to gain something. And one thing you lose, I guess, is that these large language models, they have a cost when it comes to interpretability. So there is a interpretability penalty that you have to pay by having models that are not interpretable. They also are, they fail in very unexpected ways, or you can say more unexpected ways than traditional models do. And again, you also have other things like how do you put them into production and so on. And again, in many companies, it would be a case of if it is not broke, then why fix it kind of thing, if you have only a 2 to 3% performance gain. So taking all those factors into consideration, I think it's for someone who is breaking into industry, I think it's really important for them to use to learn both the so-called classic and the so-called modern approaches, because it's not really like a progression from classical to modern. They both coexist together and have their strengths and weaknesses. So at our company, we do the same. We do heavily rely on so-called modern NLP, but we still have traditional pipelines as well.
Yeah, I would 100% sign on with what both of them said. It's particularly true that like different models have kind of different roles and can be used in different parts of the pipeline. So, I can assure you there are plenty of companies that like still have TF IDF in production for their document similarity calculations and stuff like that, because like, for example, at Primer, we've actually tested out how SentenceBird or something like that performs versus TF IDF. And the compute cost is way higher, but the performance is like not better. And so, there are all kinds of trade-offs, like Suhas said, that you have to think about. Like if I want, 5% better performance, like is the extra compute cost worth it for this part of the pipeline? Or are we okay with, just sticking with TF IDF because it's like pretty fast and it like does a good enough job? And so you have to kind of strategize about like where are the diminishing returns in terms of like whether to use an older model or a newer model, when like an older model could be just as good.
So you guys brought up an interesting topic. So I wanted to share maybe my own experience as well, and it is exactly going to agree with what you said. Specifically, when Soumya, you were talking about you were talking about this topic, it reminded me of a project that I was leading a couple years ago, and we realized, the thing that went into production, and let me also tell you what the problem was actually. So we needed to train some sort of a custom named entity recognizer that would work on a taxonomy. So we had a 3 or 4 level deep tree of concepts, and we needed to have classifiers that would tell us which concept is being represented in a textual document. And these are kind of official documents that are submitted to a body of government, so they need to be super accurate, so to speak. And why I'm bringing up this project is because we ended up realizing that, after trying pretty much everything, going from your TF-IDFs or to the Word2Vec, to the gloves, to the so on and so forth, all the way to, so this is, if I remember correctly, this was right at the time when BERT was released. So nobody really knew how to work with BERT or how to fine-tune it. So the point that I was going to bring up was we realized that this kind of meta classifier that we trained that eventually went into production was a collection of, so to speak, smart feature engineering and a bunch of very explainable and interpretable models, examples of which I could share with you are the random forests and the SVMs of the world. Some of them that were sitting in different nodes were one versus all models. The other ones were multi-class classifiers. So depending on which concept we needed to differentiate from the others, we had to go with this approach. But we realized that if we want to go ahead and use a crazy vectorizer, we are going to lose a lot of time and probably our sanity, because we needed to double check how these features are being extracted. And we honestly didn't have a lot of time and also expertise in terms of understanding how they work. So back then, there were not a lot of visualization platforms that would help you understand how certain models are going to work and how different layers in all of these models are interacting with one another. So that was just one example based on my own personal experience that I think, trying everything and then eventually going back and putting something in production that we understood how it works and we could actually plan ahead to improve it, using a feedback loop from production to, retraining. It was an interesting journey. It took a long time, but it was worth it. So with that, I want to ask you this tough question that again, probably there's no right and wrong answer, but I want to hear your thoughts about it. We see these giant language models popping up here and there every month or so, maybe. The good example was, I think, after GPT-3 was Microsoft's version. I can't remember whether it was T3 or T5. That was using a lot of compute power. Everybody was talking about how it's not good for, our carbon footprint because it uses a lot of power, and it's not really adding a lot of accuracy or any other metric that we care about. So is it worth it? Should we really continue training these very costly models, apart from the aspect of, okay, it's good for research, which I personally really appreciated. In production, do you think that other than the Microsofts and the Googles and the AWSs of the world and maybe a few other companies in APAC, should other companies, startups, students, or even smaller companies, should they actually continue working on these? Is the cost really worth it? And if not, why do you think we are having these open source version of them that is also being accessible to a lot of people?
Okay. I can start again. So I'm a bit cynical about the whole gigantic language models phenomena that is happening. I think it's for big companies, by big companies. I mean, they're just super expensive, and I like what they produce sometimes. Like I just got beta access to GPT-3 like this week, and I've been trying a bunch of things. It produces some nice text sometimes, but not consistent. But that too only in English. If I go to another language, like say I tried in my native language, and it was just producing the same word, repeating again and again in the whole paragraph. And that word is and that word is not a word. Like it's not a Telugu word. So I don't really think they're that effective. It's good to showcase, as some kind of small instance that really works. And I think it's good in general for research. But I think even in terms of research, more research should be done on what exactly are we trying to do with this, and is some kind of like, we don't have a good process for doing QA on NLP models. So I think that holds for even these models. So I don't think smaller companies have to spend so much of time and engineering effort and money on building these kind of models. I think that's the reason why they release their APIs, so that you don't have to build all these things on your own. I think there are larger problems to solve for smaller companies than using a gigantic language model. Yeah, I'll have more to say, but I just want others to also pitch in.
Thank you.
Yeah.
Personally, I think gigantic language models, particularly the open source ones, have been incredibly important in kind of just unlocking the ability to use like these modern ML or modern NLP methods by smaller companies and kind of like smaller groups. Because, like Soumya said, like they're not going to be training their own BERT because that would just cost way too much. And being able to use these language models as a starting point has actually been incredibly helpful for fine-tuning on like further tasks, even like maybe more domain-specific tasks. And so I think they've been like a really great contribution. But I would caveat that with, I want these things to stay open source ideally, and not just become the purview of sort of like private usage and licensing them away to be used by only one company and things like that. I wanted to add real quick. I should also say I've been more impressed by the contributions of, say, the BERTs of the world than of the GPTs of the world. Not to like throw any shade, but personally, I think GPT X, whatever number, is just like not very useful right now in terms of practical applications most of the time.
I agree.
So I'm a former skeptic turned huge believer of large language models based on, I think, my recent experiences with it. So I think language models are now being used for a whole lot of stuff, including uh, generating data sets for data augmentation purposes and so on. So it's about how you use it. Again, there is a distinction between open source and how large you can get, and companies like as we discussed here, a few companies keeping their language models to themselves and not releasing it publicly and so on. So there are issues like that, but there is also the fact that continuing to pre-train a general purpose language model with your own domain is showing a lot of benefits. So you can see like domain specific birds like BioBird and cyber, and even there are birds for the legal industry. There's a bird that for our financial industry too, and we have actually seen really good improvements from using that. So I think again, and there is also a lot of research that I'm pretty excited about that tries to compress the size of models. So you have DistilBird, which is pretty cool, and then there is TinyBird, and then you have all these methods like mixed precision training and quantization, pruning, and so on. So I think there is a lot of potential to make these models become much smaller and more usable, especially when you're trying to use it for inference for real-time applications. Yeah.
Sweet. Look at this. Time flies, eh? We didn't have Musti today, and yet I still have a few other questions, and we only have a couple of minutes. So I will try my best to get Musti on a different episode so that we could hear from him as well. But maybe the last question. I know we did a shout out to the Spaceys and the Hugging Faces of the world. If there's one library, repository, tool, whatever that you think that excites you, that you are constantly following a new release, a new version of them, and you want everybody on this call to give it a try, or at least try and see what they do, what would that be? So I can start maybe by giving you one example. I actually have two, but I don't want to give the second one out just in case it is your favorite library as well. So I'll start by the thing that I really get excited about, and that is called Spark NLP. They have very good community. They run a lot of workshops as well. So again, right underneath Spacey and Hugging Face, I would say Spark NLP is something that I really like, and I always follow them. And I'll pass on the mic to maybe this time, Charlene, you want to go first, and then right after that, if everybody answers this question, then we can have a closing remark and end the first episode.
Yeah, totally. I'm a big Streamlit booster. So Streamlit is like a little tool that you can use to basically spin up web apps that are like very data science heavy, or like basically like front-end interfaces that you can use to like train a model or like display a dashboard or some other kind of results. I know a lot of people use like Plotly Dash and things like that for dashboards already, but like you can use Streamlit for that. There are a lot of different use cases. They have a whole gallery on their site, and you can check it out. But I was one of their early users, and I was like, man, this is way better than like learning to write a Flask web app. And I feel that way every single time I use it. So yeah, that one, and then as kind of a secondary sort of related one to that, Fast API is getting a lot of attention lately in terms of quickly spinning up an API, for example, to like serve model predictions from. So that you can kind of just hit an endpoint and get access to a model right away. So I would definitely recommend looking into that if you're also tired of writing Flask endpoints and you don't need an interface, you just need like a prediction API. Go ahead and check out Fast API, and check out Streamlit if you need like an actual like proof of concept front end for some kind of data science application.
Okay.
No, you can go ahead. I'll do that.
So maybe one library that I would like to give a shout out is Expert or sentence transformers. So they are used to generate sentence embeddings, and I would call it like the Swiss Army knife of modern NLP. I use it for a variety of different tasks. It's pretty convenient to use. In fact, and it's also works pretty well out of the box and easy to train. In fact, I remember my colleague, the first time he saw it in action, he had a religious experience. It works so well out of the box. So, yeah.
So I recently started using Stanza for doing some research project, and I really liked it. I mean, I used to use Spacey a lot before and Hugging Face, but I actually realized it's very under recognized. I mean, I used to use Stanford Core NLP a lot when I was coding in Java, but I didn't use anything from them in the past few years, and then started using Stanza in the past like 1 or 2 months. It's actually quite good. It's like it has some good training routines. The documentation is not sometimes ideal, but it works. And they have some specific models for doing clinical NER, like some pre-trained models, and there are some tuning routines. So I found it quite good and like a pleasant surprise as of now for the kind of work I do. Other than that, I have some very old-fashioned recommendations, awk and grep. I use them a lot these days, every day. And even after all these years, I think they're among the most useful tools for anyone who is working with text data. I didn't use recently, but I found Gensim actually very useful when I was working on industry projects. I used to use Doc2Vec a lot at the time, like Suhas thinks sentence transformers is a Swiss Army knife. 2 or 3 years ago, I used to think Doc2Vec is that Swiss Army knife. Doc2Vec implementation in Gensim, I used it a lot for many different kind of problems at the time. I'm sure it still exists now, but I don't know how it performs in comparison with more recent models like BERT.
Sweet. So what I will try and do is maybe collect all of those recommendations from the 3 of you, and I'll post it on the Weekly Supervised Slack channel, just in case anybody wants to give them a try. So the other thing I wanted to share with everybody is a community called Rasa, R-A-S-A. I think they are based in Germany, if I'm not wrong, but they are kind of the very first open source chatbot, chatbot community. They have, I think, 2 or 3 separate ecosystems, but I really fell in love with them when I started working, using them for a specific chatbot project a couple years ago, and they are getting better and better pretty much every quarter. So if you are interested in building a chatbot and you don't want to just go ahead and use things such as Dialogflow, definitely give Rasa a try. Again, they are open source. They have a lot of great documentation, a great community, a perfect YouTube channel where they do live coding and they read papers together. I really like them. So shout out to them again from me. With that being said, and I know we are past the mark of the hour, I just wanted to thank the 3 of you, Suhas, Charlene, and Soumya, for spending the time out of your busy schedule. I know this is a Friday, but it's still working hours, so I really appreciate you taking the time. I really hope that we could have you back as an individual guest so that we could talk specifically about the projects that you've been working on, your team, your standardization method when it comes to data science generally and NLP specifically. And I also wanted to thank the folks who have been listening to us for the past almost an hour or so, or joined our Slack channel. Again, a reminder, there's going to be another one of these events every week, every Friday at 2:30 Eastern time. So the links to the YouTube lives are already posted. You can find it in the same channel. Please subscribe, join our Slack workspace, and we're going to share a lot of cool stuff over there with you. If you have more questions that we didn't get the time to answer, please share them on our Slack. I will hunt these three folks down on another Slack channel and ask those questions from them. But all joking aside, this was a pleasure. I really enjoyed doing this with you guys, and thanks again for the time. Looking forward to having everybody back, hopefully next week, same time.
Yeah, thanks to you and to everyone here. I really enjoyed getting to connect with all of you and hear your perspectives on these questions too. So yeah, this is great.
Yeah, thank you very much.
Yeah, thanks, Arman. It was great.
All right, have a great
And,
weekend,
thanks
everybody.
to all the co-partners.
Yes, have a great weekend, everybody. And the four of us, we're going to be in touch. But for everybody else, please get in touch with me on Slack. We are also going to have a new team member joining us for a few of the future events, and then hopefully we will have better marketing and better reach outs. Some of you have asked if we could, open the live chat on YouTube. Definitely, this time it was super hard to kind of keep track of everything. But once we have Amber on board as well, definitely we'll continue doing that. Thanks for your support, and looking forward to having another chat with you, hopefully next week. Bye for now.
Right.